Okay, this video gonna help you with solving this problem. And I think some of you may stuck with this B2, VB2. Since you don't know the direction of VB2 after impact, and you may have difficulties to solve the rest of the problem. So let's look at this problem together. I will give you a hint of how to solve this problem. So let's look at the given condition here. So before impact, we know A is moving to the right, VA1, and B is moving to the up, VB1. And let's set up a coordinate system first. So we know coordinate system here in the impact problem, we have Tn system, right? So this is N, this is T. If you don't like T and N, we can replace that with Y and X. And you're probably familiar with XY coordinate system better. Okay, now if we're using XY coordinate system, so before impact, VA1 can be written as something I plus something J, right? And since it's only moving to the right, we can write VA1 as VA1 on I direction. Similarly, for VB1 is only on J direction, so we can write that as VB1J. Okay, now let's look at after impact. VA2, after impact, we know mass A is still moving to the right, so we can write that as VA2I. And for VB2, that is something we don't know the direction. However, you can write that as VB2X, that's your X component on I direction, plus VB2YJ. So this is how I approach this problem, by breaking VB2 into two components. Even you would think we're introducing two more variables here, but this VB2, it's a magnitude of these two components, right? So VB2 square should equal to VBX square VB2X plus VB2Y square. So this is a relationship we can have between VB2 and VB2X, VB2Y. Okay, that's very important information you may need later. Now let's look at the coefficient of restitution. Since in problem 6 you need to solve what is E. So remember the definition of E equals negative and VB 2n minus VA 2n VB 1n minus VA 1n. Okay, and that's the definition of this coefficient. And if you look closely, all the v's inside of this equation are only on n direction. In our case, that is our x direction. And so that tells you if you want to solve for this coefficient, you can only use the velocity on I direction in those given conditions. So let's write that out. That equals negative. So since we need VB2n, that's the velocity of B on I direction. Since we break it down, break the B velocity of B down to x and y component, so we can just use this VB2x. VB2x. That minus VA2n. That's the velocity of A after impact. So we know that value equals VA2. Okay, on the bottom here, what is VB1? So velocity before impact on n direction. If you look at B, that before impact, B has no velocity on n or x direction. Therefore, that is 0. This term minus VAN1, that's the velocity of mass A. before impact, we know that is VA1. VA1. There you go. If you look at what we have here, this is given. VA2 is given. The only thing we don't really know is what is this VB2X. However, we know this VB2X has a relationship with VB2, and VB2 is given, and if we can solve what is VB2Y, we're able to solve what is VB2X, and we can solve what is E, if that makes sense. And you can start from here, and I will give you a hint how to solve this VB2Y, and you can apply the conservation of momentum on y direction, which is this t direction, to solve for the system A and B, to solve VB2Y. All right, good luck. Thanks for watching.